This is an explanation for question 21 of the 2021 AMC 10B, paper folding. A square piece of paper has side length 1, and vertices A, B, C, and D in that order. As shown in the figure, the paper is folded so that vertex C meets edge AD at point C prime, and edge BC intersects edge AB at point E. Suppose that C prime D is 1/3. What is the perimeter of triangle AEC prime? We will obtain the solution using the properties of similar triangles. Set the point where the fold occurs on CD as F. Then set DF as X, then C'F as 1 minus X, since C'F equals to CF due to the symmetry of folding. In right triangle DFC', we can get an equation using the Pythagorean theorem. X squared plus 1/3 squared equals 1 minus x squared. Solving the equation, we get x equals 4/9 and also get the length C'F, which is 5/9. Since 1/3 can be written as 3/9, this is clearly a 3-4-5 type of right triangle. Now we have all the lengths marked. Since angle FC'(E) is 90 degrees, triangle AEC' is similar to triangle DFC'. And since both triangles are similar, the perimeter of triangle AEC' is simply the perimeter of triangle DFC' multiplied by the side length ratio, AC' over DF. Thus, we get the equation 3/9 plus 4/9 plus 5/9 multiplied by 2/3 over 4/9, which equates to 4/3 times 3/2, which is simply put just 2. Thus, the perimeter of triangle AEC' is 2 units long. This AMC problem reminds me of other interesting properties in paper folding. In origami, we usually fold a square piece of paper into fourths or eighths and form grids to help us in the process of making. However, when we need to fold a paper into thirds or fifths, it is much more difficult to fold precisely. Here, we have two simple methods to fold a paper into fifths. This is a square with a side length of 10, and E is the midpoint of AD. Say we draw a line through F to get 2 points G and H on the side lengths, we can form two similar triangles, EGF and FBH. If we apply the same strategies we used in the previous problem, we can figure out that the yellow line is exactly 1/5 of the whole side length. Thus, we get the first way of folding a paper into fifths. This is the second method of folding a piece of paper into fifths. By following the images above, it is quite simple. Although it is slightly more challenging than the first method, it is more widely used when folding paper for art, since the point of intersection, as shown in the last image by a dot, is 1/5 not only from the right-hand side, but also from the top side. Therefore, no matter which way you fold it, it will always be 1/5.